Hi, and welcome to my individual project demonstration video, magnetic levitation using bulk superconductors with outreach mainly in mind. So before we start to get into anything, I'd like to explain a few of the technical words that are going to be needed for our video and for the project in general. So magnetic levitation is a really interesting phenomenon in which an object appears to hover or float above another object. In the context of our project, bulk superconductors are the object that will be floating above the permanent magnets. So bulk superconductors are, in our case, they're ceramic, but in general they're materials that when cooled at extremely low temperatures exhibit something called the Meissner effect. In other terms, the Meissner effect is when the bulk superconductors repulse or push away all the magnetic field that they are exposed to. So now that we know some of the technical terms that are needed, come with me to find out a little bit more about what the project looks like and how it works. So this is the main deliverable for my project, the vehicle. So I think immediately something that springs to mind is that it's very, very flashy, very red. This was made because the main objective of this project is outreach, and we want to show people that this technology is very accessible and make a complex physical phenomenon into a fun and engaging demonstration. We wanted to make sure this vehicle was attractive and aesthetically pleasing to make it really engaging for our audience. And we also wanted to make it London themed. This is why it's been painted bright red, as we can see, and this is also why I've added the Union Jack flag. So this whole vehicle was designed using Fusion 360. Inside of here, as you can see, are the bulk superconductors that I've glued to the vehicle itself, and they're inside of the holders. Let's remember, those bulk superconductors only push back magnetic field when cooled at very low temperatures. And in our case, we've used liquid nitrogen. The whole of the vehicle inside is lined with plastic epoxy. This is because the liquid nitrogen, if it interacts with the plastic directly, will make the vehicle very, very brittle and fragile. On the side of the vehicle, as we can see, are wings that will be used to help propel the vehicle on the permanent magnet track, using the propulsion system that is essentially two fans. So let's see some visuals of the permanent magnet track and the propulsion system. Also here we can see the lid, which as we can see has 3 holes. These were drilled because the pressure of the liquid nitrogen would have made the lid blow off, and this lid is mainly used to be put on the vehicle like this and to keep the liquid nitrogen from boiling off too quickly. So it's experiment time. Let's find out a little bit more about what it looks like when it's working. So in here we have the liquid nitrogen. This is my vehicle. This is the final design for the track. Okay, so now that the liquid nitrogen is on, we're going to let it cool for a little bit, and then in a few minutes we'll test it on the track. Alright, so it's cool enough. We've put the lid back on. Now let's see how it looks on the track. Have another shot of it levitating. Which was really the main objective of this project, and I feel like we were really able to provide a fun and engaging project for everyone. We really wanted to make it family friendly and safe, and I feel like with the way the track was designed and the vehicle was made, you know, with the red colors and the wings and the flashy design, we were able to do that as well as also making it safe. The lid that goes on top of the vehicle also serves as a protection from the liquid nitrogen, because in case of any spillage, liquid nitrogen can induce really bad ice burns. The applications of this technology are varied, with the transport mainly being the one that this project focused on. The potential social benefits that the implementation of bulk superconductors can bring are really varied. For example, a bulk superconductor transport system uses much less electricity, especially with the cooling, than a traditional electrical train or diesel train, which is really important because sustainability considerations are key when it comes to our responsibility as engineers. Overall, I hope you've enjoyed this video as much as I've enjoyed making it, and thank you for watching the bulk superconductivity demonstration video.